Hello everyone, I'm engineer Ayman Okail, electrical engineer. We will talk today about BIM technology. We'll introduce the advantage of using BIM in projects, and we will also show a video from Autodesk for the presentation of BIM. We will talk after that about document set organization and the naming conventional for the sheets exported from Revit, and we will show a 3D BIM model for some projects from our team. Also, we will show the exported drawings, and we will talk about the 4D time simulation and the 5D cost integrated model. We will show also rendering samples and PDF and videos produced by Revit and Lumion. After that, we will explain using dynamo codes and Revit add-ons in order to facilitate our work. Okay, first, talking about the BIM technology, we use BIM including many programs like Revit and Navisworks and many other programs which allow us to make a full coordination for our project and produce a zero clash model, and also it allows us to visualize our project, to see every part of our project in a 3D and produce sections and callouts so easily without any extra time like using CAD before. Now we will play a video which show how is engineering was done in the beginning before from long time, and how is this process has been integrated one by one. Now we are talking about the design in the from long time. It was done by hand, and it was ordered inside directly, do this and something without drawing. This is for example. And the project is delivered on time and so on. After that, change it to drawing board, and all the engineers draw by hand on drawing board and so on. This is the 19th century. And after that, it changed to CAD using the computer. It was more easier. After that, it changed to 3D using 3D Max and many other programs. Like you can see, you can simulate your project in 3D as you see. After that, there was changing to BIM, which have a lot of advantage, as we said.
Engineers and construction professionals, it's critical to have the best possible information about a project to make the right decisions. Important shifts in the industry are happening. Yesterday's disconnected ways of working are in the past. Today, new efficiencies are being realized. Thanks to Building Information Modeling, BIM. BIM is the creation and use of coordinated, consistent information about a project. Information that enables you to visualize designs in context, accurately predict performance, analyze real-world structural behavior, and make design decisions earlier in the process, all before the project breaks ground, helping thousands of architecture, engineering, and construction professionals streamline the way they work, increase productivity, and create high-quality projects by pushing the design boundaries and ultimately gaining a competitive advantage.
We can see now sustainable design, how we make our design more sustainable. By making the best orientation for the building, to use sunlight, for example, how to make sustainable design for water. All of these are done using BIM. That's it. So we find a very big difference using BIM technologies and engineering that done before. Okay, now before going through the BIM 3D modeling, we will talk about the naming conventional and document set organization for our production using BIM, the naming conventional of sheets and so on. For example, we can see here in any project we have many folders. Each folders, this is our naming conventional. Each discipline has its own folder, and each folder contain BIM, CAD, calculation document, for example. And for example, in the BIM folder, you will find building coordination, families, and so on. Also, after that, we have the sheet ID. It consists of 4 parts. First, the project number, for example, this one. Okay. Then, after that, the building number, which is B01, for example. After that, the sheet number, and we will talk about this in details, and the revision mark. So, first, in the sheet number, which is AC101, this is, for example, the first letter is the discipline letter. For example, A is architecture. For electrical, we will put E. For telecommunication, we'll put T, and so on. E is a sheet modifier, which means that A, architecture, and C, for example, is ceiling. This is the sheet modifier. For example, in electrical, we will put E, and then instead of C, we will put L, for example, for lighting system, and P for power system. After that, the first number is the sheet type designator, which stands for planes. If we have planes, it will be 1. For example, we can see here, if we have planes, it will be 1, elevation will be 2, 3 sections, 4 large scale view, and 5 type and details, 6 schedule and diagram, 7 discipline define, and 8 discipline coordination sheets. And we have, if we have 3D presentation, we put 9. So these numbers are put in this place, okay? And after that, 0, 1 is the first level in our project. For example, if we have 3 basement, this will be the bottom level in the project. It will be 0, 1. If the first level in our project is the ground, so the ground will be 0, 1. After that, the first will be 0, 2, and so on. Okay, this is a naming conventional. Of course, we have made some exceptions for anything, and this is the naming of the files of the Revit and so on. For example, if you have a model for the architecture drawing, for the architecture BIM model, the name of the file will be the project number, then the building number, then the discipline, A for architecture, E for electrical, and so on. Okay. This is about the naming conventional. After that, we will show you a 3D model for a project. For example, we can see something like that. First, this is a project done by our team. This is a restaurant in KSA. It's done a design with LOD, which is a level of development 300. As a design drawing, it was done totally in Revit. We can see here, this is a 3D model of our project. Okay, we can go in details a little. For example, we can see here the restaurant. This is 2 seating area on the right and on the left. As you can see here, and this is a decorative lighting fixtures, and this is above the full ceiling in the kitchen and so on. We can go down more a little. For example, this is the kitchen, and this is the bathroom, and so on. And we can go up to the first floor. For example, here is the male sitting area, and here is the female sitting area, and we can go above. We can see here is the family sitting area. Okay, and this is a board and so on, and lighting feature, and the bathroom, and the kitchen above, and the offices. And we can saw behind there is the HVAC equipment, like this. Okay, this is a restaurant, and you can see here in Revit also the sheets are done totally in Revit. This is, for example, the cover sheet of the electrical, and this is the naming conventional sheet for the project which we were talking about. It explains everything, sheet modifier, sheet naming conventional, and so on, sheet types, and general electrical notes, and abbreviations, a drawing list, okay, and the legend. And this is a sheet for showing some 3D and isometric views. This is, for example, the routing of the cable tray. This is a rendered image for the first floor family area, showing the lighting. And this is, for example, showing the panel boards and the cable trays and the exit sign and so on. After that, we can see here there is a cable routing, lighting, power, and typical installation details, and like this. For example, if we see the cable routing drawing, we can see the sheet which shows a cable tray, for example, something like that. Okay, we can see a sheet for lighting system which show the lighting fixture and the wiring and so on, for example, something like this, with the circuiting and wiring and everything. Power, this is power, sockets and isolating switch and so on. After that, there is the panel schedule, the calculations for the loads, and the single line diagram. Okay, all of these are done in Revit. Also, we have another discipline, which is telecommunication. It also has the cover sheet for the telecommunication, naming conventional and system, and drawing list for the telecommunication system, as was shown before for the electrical, and ground floor for the CCTV, for the camera system. We have fire alarm system. For example, and we have public address system, which is sound system. As you see, the sound system done with wiring and volume controls and so on. We have the structural cabling system, which includes the telephone and data and wireless and so on. It's a cable tray for the low current, and of course the installation details for the telecommunication system, and the racks and so on, and the riser diagrams for each system. So this is a project in 3D done totally in Revit from A to Z, using Revit modeling and creating sheets and everything. Okay, I can show you another example for another project. This is project shop drawing. The previous one was done with LOD 300. This project is done with LOD 350, which equalized to the shop drawing. This is King Faisal Specialized Hospital in KSA. It was done by our team. Also, this is a 3 model for one building in the hospital. The total project area was 2 million meters square, which contain of many buildings. This is one building, for example. It was done all the systems, architecture, structure, and MAP, full MAP, electrical, mechanical, plumbing, firefighting, and everything, with our team. Okay. This is, for example, I can show you one level above the false ceiling, which contain the MAP works to see in 3D. Okay, you can see here above the false ceiling all the electromechanical works in 3D. The lighting fixture, everything the duct for HVAC, the firefighting conduits, the firefighting pipes, and the water pipes and drainage pipes, and the cable trays for electrical cable trays and low current, everything. This is above the false ceiling. The air diffusers and air grills. This is, for example, this is all the MEP work, coordinated, zero clash, above the false ceiling for such projects. Also, I can show you a sample for the exported sheets for such projects. We can see, for example, the cable routing sheets, which is exported from Revit from this project, which shows every single cable tray with a schedule and numbering for all the cables inside the cable tray, and another sections for the electrical rooms, showing each wall in a separate section, and the call out for the electrical rooms. You can see together. Okay, it's something like that. Also, it's showing the supports for the cable tray every 1.5 meters. Okay. This is the schedules for each cable tray, and the sizing of the cable trays, and the number of the cabling, and which one on the left and on the right to avoid any crossing for the cables. Okay, and this is the call outs for the electrical room, showing the panel arrangement inside the electrical room. This is, for example, the call out for each system, for the critical cable trays, for the normal cable trays, for the cable trunks, for the outgoing and incoming for each panel. Okay. So that we have sections for each wall, showing the panel boards and the incoming conduits or cable tray, for example. As you see, these all sections and call outs are exported from Revit without any extra effort. You can make a section in Revit in 1 second, just to click and create a section in this area, and it will give you all the information needed, for example, like this. Okay. Call outs. As you see. Also, we can show there is for lighting and panel pose and power, and also for security, for example, which shows the security systems for the low current telecommunication and the installation details. We have a drawing like this, and this is a cable tray for low current and feeding access control system and so on, and there is the details for the access control. As you can see here, for example, this is the door and the sensors and all the equipment for the access control panel as detail, and this show the sorry, and this show the sockets on wall for data and telephone. Okay, and this is showing the installation details for the camera system, CCTV system, showing how to fix everything, as you can see here, for example. Okay. Okay, this is an example for the example for the security. Okay, knowing that all all our team which who is participating in such a project are certified professional from Autodesk. For example, I can show you this is my certificate, Autodesk Certified Professional from Revit MAP in Okail. All the team working in the project are certified professional. After that, we can talk about. We talked now about the 3D modeling and the exported drawing from Revit, showing all the detailing. Now we will talk about the 4D time simulation. What is the 4D time simulation? The 4D time simulation, we can make a visualization for our project in each day or each week in order to see the status of the project. How we make this simulation? It's done on a program called Navisworks, where we attach the output of the Primavera planning file. We import this planning Primavera file into the Navisworks, and we connect each task in the Primavera to its corresponding object in the model. For example, we connect the foundation task in the Primavera, where we can see here, okay, to the objects regarding the foundation of the first floor and the second floor and so on. So after that, we finish all the tasks for the project to be connected to each object. Okay, after that, we make a simulation. As you can see, this is a villa. You can see everything is done for the villa and the HVAC and everything. Okay, if you want to see the status of this project at the beginning, we can see something like this. This is a foundation. Okay, you can see here. We can set our date. We want which date. This is for the first date, for example. If we want to see after 2 weeks, for example, we can see this is the concrete are done. And if you want to see after 1 month, this is the concrete done for all the levels. If you want to see after 2 months, for example, this is the bricks are done and the glasses and so on. And if you want to see after 1 more week, it's done the painting. After that, we can see all the HVAC are done. We can make a simulation for this. Okay, you can see here the day, the hour, the week for the project. It's building according to the tasks from Primavera. As you can see, this is a concrete done for the grounds and the first floor and then the second floor. Showing the sequence of the project. This is a plan for the project, the status of each day and each hour for the project is simulated by Navisworks. And also by doing this, you can see if anything in the planning have to be done before or after by visualization, which allow you to see the whole picture more accurate than just making a task for the planning. We here are in the day 51, day 52, in the 8th week, and the painting are done. And the equipment of the HVAC are done on the roof and so on, and the facade, as you can see. So this is the 4D time simulation. Now the project is finished. Okay, this is an example. We will talk also about the 5D cost integrated model. Okay. The 5D cost integrated model it's what is a 5D? It means that we attach the cost of the project into the model and to extract any information and get a BQ for the project in one click like this. If you can see an example, this is a BQ done for a project extracted from Revit. We didn't put any we didn't modify anything in the Excel file. We just take this Excel file output from the Revit. It contains the division, the title, the section, and the description for the item, and the item itself, and the unit, the quantity as per the model. Everything is done automatically from Revit without modifying anything in the Excel. All this information are done in the Revit families, so we can extract easily, as you can see. Nothing made in the Excel, nothing modified, just exported from Revit in one click. Okay, you can see, for example, and this is utilizing BIM for sales. If you have, for example, an apartment, a compound or something like that, and selling units, so you can see each unit has a section box in the Revit, as you can see, choosing another unit, showing each one and the architecture. This is unit E1 208, for example. This is all the units. After that, automatic generation of BEQ based on the client flat. For example, we have a client flat which selects which flat number, and we have the finishes quantities, as you can see, marble, flooring, and so on. We just choose which unit, and it tells us every details about the finishes and how much area, quantities, and so on, and the total cost. And if you want to change, if the client, for example, he want to change the flooring from wood block flooring to be, for example, marble or ceramic tiling. If you choose ceramic tiling, we find automatic. It's changed in the BEQ schedule to be ceramic with the quantities. After that, if we change to marble, automatic, it will be changing the quantity and also the cost updating. We just change the material, and automatically the cost is changed. We don't have to calculate the area for the ceramic, how much, then we multiply about the multiply times the rate of each item, then we get the total cost. It's done automatically. We just click and change on the flooring, and it automatically change the quantity, the area, the rate, and the total cost for each unit. Okay, we will also show a dynamo showing the cost. We just, if you want to select any object in the project, we want to know the price, we just run the dynamo and we select, and we see here the price. As we can see, we can for example isolate the MEP work and select them, so we can get a price for the MEP. We can isolate only the first floor to see how much cost. We can isolate the concrete works. Anything we want, we can isolate, and just clicking by the mouse, and we will see the price. Now here is a rendering. This is a simple rendering for a project. It's done by Revit and Inkscape program. When we just add anything in the Revit model, it's done and seen as a rendered object, as you can see. This is a very, very simple rendering. Okay, and also we create a model navigation for client use by using arrows just to navigate inside the project or the apartment or the flat, for example, something like this. And if you want to enter, for example, any other room, this is, if you go to the bathroom, for example, you can see the walls and everything. This is another bedroom. You can see the kitchen, for example. Okay, that's it. I show you now a rendered for the project. Can show you more rendering samples in PDF and video using Revit and Lumion. For example, for the exterior design, this is rendered and done by Revit. As you can see, all this material and rendering are done by Revit and Lumion. For the interior design, you can see something like this. This is also done by Revit and Lumion. This is a high quality rendered. It takes a lot of work for modifying the materials before it starts the rendering. Something like that. You can see the sunlight here and the artificial lights, and the camera angle which taken from for the shot. For example, here is the Zamalek logo. Some client requested something like that for the children, and you can see here the sunlight coming from the window and so on. It's a TV, which looks like a real image taken by the camera, not done by Revit or rendering. And shop drawing, we already seen samples for shop drawing, and for this is for the landscape and so on. And for the dynamo, we already showed a dynamo. This is, for example, the code of the dynamo, which for making the cost when we show in the previous video, by selecting only the object in the model, it automatically show the cost. This is the dynamo for such a code. It's a visualized visualized code. Okay, where we instead of creating the code by hard coding and typing, for example, C++ or something like that, it's put every code in a box, as you can see, and by done this wiring and adding each one to the function exactly suitable for it, so we can get a dynamo. There are many dynamos which done also by us. For example, we have make a lot of dynamos aligning the lighting fixture. When you place the lighting fixture in the project, have a dynamo, it's all automatically center the lighting fixture inside the ceiling tiles, change the circuit breaker rating and naming automatically by the dynamo. Many examples and many things done by dynamo in order to facilitate the work and make it more accurate in a very less time than usual. Also, we can see a sample for the rendering, but in a video. This is done by Revit and Lumion. I'm making the video forward in order to see quickly, take an overview. Okay, for example, the video is done where you can see where you can move quickly and fast, and where you can stop and make it a little slower and go up to see the whole view. It's a matter of direction of the video. Okay, I can show you another video. This is, for example, a private villa. It's done by Revit and Lumion also. As you can see, all this can be produced by using BIM technology. Also, there are many add-ons which facilitate the work, like the BEQ exporter, which we export this BEQ file using. It's done also our team family manager by adding parameters, the cable exporter, linked ID, where you can know the ID of an element in a link inside the Revit. Increment tagging, it's like the Lisp in CAD, where you can add numbering just clicking on the item, and it automatically add the tagging with the numbering, suffix and prefix, and so on. That's it. I hope you enjoyed my video, and thanks for watching, and see you. Bye bye.